Hello all, welcome to the next topic from electrostatics. This is already written in the board. Motion of a charged particle in an electric field. So we know electric fields are emerging out from positive charges and electric fields are coming into the negative charges. So within the electric field area, when I started with the electric field video, I already told you that electric field means it's an area. There certain rules and regulations are there, and outside the area there is nothing, we can free to move, but within the area we have some rules and regulations are here. So it's an electric area, it's a charged field area. So what will happen if a charged particle is entering to that area? There are a lot of tricky questions are normally coming from this area, especially for Neet and JEE examinations. Okay, not very frequently asking, but there are questions will be there. So we will see how we will tackle this, how we can tackle these questions. Once we understood the concepts very clearly, definitely, of course, the answering of the question is also quite easy. So we'll start. I have a positive plates, which means this is positive charges. So everywhere I have marked with positive. I have a negative plates similar to this one. I have a negative plates. So this is all over a negative charges. Okay, we will take both are the same size. So I have a positive plates. I have a negative plates. So both are with positive and negative charges. So we know the electric fields lines are coming out of positive charges and coming into the negative plates. So here I am going to draw the electric field lines with these blue lines. So coming positive to negative, positive to negative, positive to negative. You can draw any number of lines, but to make the things diagram more simpler, I have only drawn like 3 lines. So electric fields are starting from positive and ending at a negative. We have properties of electric field will be there, right? So the one of the major property of electric field lines are electric fields are starting from positive and ending will be at negative. Electric field lines are parallel to each other. Electric field lines will never crosses each other, they will never cut each other, so all are going parallel. These are actually the main properties of electric field lines. Okay, so electric field lines will never crosses and which are parallel to each other. We will deal this in some sessions also. Okay, so now I have an electrons will be here. I am assuming I have an electron. So this is the field where electric fields are existed. Now I am shooting an electron into this one. I am just placing one electron like this one. So what will happen? These electrons will move, and here there is an electrostatic force will be there. We know Coulomb's force will be equal to 1 by 4 pi epsilon 0 Q1 Q2 divided by R square. If you are taking these terms, maybe first Q1 by R square, we can say 1 by 4 pi epsilon 0 Q by R square is called electric field, and electric field into next charge Q2 is called electric force. So in short, in our textbook and all, we will write Q into electric field intensity. Correct. This is the normal equations we have learned in the relations connecting between Coulomb's force and electrical force. So electrical force will be here. Here force is a vector quantity. We'll put a vector notation, arrow mark. Charge is not a vector quantity, scalar quantity. Electric field is a vector quantity. So the electric field arrow mark also we have placed. What this is indicated to us, the direction of electric field is same as the direction of force because charge is a scalar quantity. So if you are asking in this relation what is the direction of electric field, I am saying the direction of electric field in the positive x direction. Then the direction of force is also in the same direction. There are no differences. So E and F directions are same. Now we'll see will be here in this case, we'll apply this equation will be here. We know the electric field lines are marked like this from top to bottom. So what will be the nature of forces? So F will be equal to, in this case, Q into E will be there. So what is Q? Q is here I am considering as an electron. Electron is negative charge. So F will be equal to EE. I am putting one negative. So if it is positive, then F is equal to QE. F is in the same direction of electric field. Now F is negative. Why it is negative? Because electron is negative. That's what I am written. F is equal to minus EE. So instead of coming, electric force will be like this one. Now the electric force will be in what direction? Electric field is in the downward direction and electric force is in the opposite direction. Normally if the charge is positive, suppose if it is a proton, then I will write F is equal to EE plus EE. Plus EE means the direction of force is same as direction of electric field. If I am getting force is negative, electric field is positive, then force is opposite to the direction of electric field. So now in case of electron, force is like this one. Okay, now what will happen when an electron is entering into this area of an electric field? An electric field is already exists. This electric field will create an electrical force that is called Coulomb's force. F is equal to minus EE, and minus EE is in this direction and plus EE is in this direction. So here we have force, the direction of force is opposite to the electric field because of the negative sign. So here there is an upward force. So whenever a charged particle, electron is placed in an electric field area, a force will apply, and due to this force, electrons will move. In what directions electrons will move? Electrons will move towards bottom or electrons will move towards up. Here force is up direction. So somebody is lifting the electron. If somebody will lift the electrons, what will happen this electron? These electrons will move like this. These electrons will move like this one. So this is something like what you have learned it in on your plus 1 physics or 11th physics. This is something like a similar to a trajectory motions. Okay, it is something like a two-dimensional motion. We are going out of one-dimensional motion. So it is a two-dimensional motions. Now we'll consider this length of this plate, positive and the negative plates, which is marked will be here, will have an x meter distance. And from this original positions, this electron is shifted a y meter away, and initial velocity I am placing to this will be V0. V0 will be the initial velocity. We will write a couple of equations in the x and y direction because it is a two-dimensional motion. For a two-dimensional motions, we need x equations and we need y equation. Why I am saying it's a two-dimensional motion? Because this electron will be following a trajectory motion. So we have to write x equations and y direction equation. X and y, two-dimensional quantity, x axis and y axis. So in x axis, we know the general equation S will be equal to ut plus half at square. This is a quadratic equation, its power is 2, and this is a two-dimensional motion. It's a parabolic shape. Okay, so we'll substitute. S is the horizontal distance, x direction, so S will be equal to x. What is the initial velocity? V0 in the x direction, only x direction, not in y direction. And the time is t, equal to half into, what is the velocity in ax direction? Electron, if it is an electron is placed in this direction, then the initial velocity will be there. After that, there is nobody will be there to accelerate in the x direction. Nobody is pushing like this, right? If nobody is pushing like this, means the accelerations in the x direction is equal to 0 and it is t square. So what will happen? X will be equal to V0 into t, and t will be equal to x divided by V0. This is what we got. Now we'll go to the y section also. In the y section, same equation, S is equal to ut, but in the y direction, instead of S, what is coming? Y. Now our focus is only on this y axis. So ut, what is the initial velocity in the y direction? There is no initial velocity. Initial velocities are in x direction. So it is 0t, 0 into t, half a t square, half into a y into t square. Why I am putting a y means accelerations in the y direction, a y t square. We have to find out what is called a y. Look back, one step back, we know F is equal to QE. What is the, from laws of motion from first year, what is F is equal to? MA, mass into acceleration. It may be in x direction, it may be in y direction. Y direction we have an acceleration because its speed is increasing in these directions. So this is nothing but MAY is equal to Q into electric field. So here we will got AY will be equal to QE divided by M. This we can place it will be here. So we are going to substitute y will be equal to half into QE divided by M into T square. For the T, whatever we got it from X, we are substituting here. So Y will be equal to 1 by 2 into QE divided by M, T square, X by V. So X square by V naught square. From this, it's very clear that you know Y is proportional to X square. This is what kind of equation in mathematics? In 10th standard and all, you have learned some equation, something like this one, right? Y is equal to 4ax square. Draw the graph for this one. Y is equal to 4ax square. You are drawing, you have drawn many graphs, right? This is a graph representing a parabola. So Y is proportional to x square. Parabola is a two-dimensional quantity. It's a two-dimensional nature. That's why Y is equal to 4a square. Y is proportional to x square. We also got in the same relation in this case also. So Y is equal to half into QEM into x square divided by V naught square. This equation is important. This equation is very important. Now, this is a concept, we got it, and here there are some chances to ask a few questions for your entrance examinations. I'll tell you what kind of question is coming from this area. The question is coming from the area, you know Y. Okay, listen very carefully. You know Y. Y is actually the deflection, how much height it is moving or how much it is deflecting. So Y is actually related with the amount of deflections in the Y direction. Remember that point. We'll move to one more case studies will be here. We are again applying the motion equations and we'll see what is coming for us. We know we have a lot of set of motion equations. V is equal to U plus AT. So V is equal to U plus AT motion equations applying along the X direction and along the Y directions. Along the X directions I am applying V is equal to U plus AT. So this is similar to this one, right? V is equal to U plus AT and in the Y direction also. So we can write Vx equations. Vx will be equations. So Vx will be equal to U plus A into T. What is the accelerations along the X direction and what is the final velocity in the X directions? So this is hard to determine in this case, right? Vx is hard to determine. A will be equal to 0, that we know along the X direction, and U we know it is equal to V naught. So if you are substituting AT, A is 0 along the X direction, so this is nothing but 0. So the initial velocity only we know in these cases. So here we will do some mathematical analysis based on some trigonometry instead of using another further motion equations like V is equal to U plus AT, V square equal to U square plus 2AS. We'll do some analysis based on this one. Now we know this is deflecting like this and this deflection angle is given as theta. And this deflection angle will be given as theta and theta will be equal to, how we can calculate? Theta will be equal to, theta is equal to theta, tan theta. I am taking tan theta. Let me draw this triangle alone will be here. So a triangle will be something similar to this one approximately. So this is what we call theta and here we have a Y component and up to this we have X, but we have something. So here this component I am taking as velocity along the Y direction and this is velocity along the X direction. Velocity along the X direction, tan theta. So tan theta will be equal to Vy divided by Vx. Y directions velocity we have to find out. What is Vy? Vy will be equal to, V is equal to U plus AT equations we will apply in this Y direction. So Vy will be equal to U plus, I am writing the general equation, U plus AT. So Vy, initial velocity in the Y direction, there is no initial velocity, only in the X direction we have initial velocity. So this is 0. What is acceleration in the Y directions? We already written, right? So we will substitute here QE by M into T. So this is the velocities in the Y directions and we know the velocity in the X direction is the initial velocity. Okay, so Vx. Now we'll substitute tan theta. Tan theta equal to Vy by Vx. So Vy QE divided by M into T whole divided by, what is Vx? Vx means velocity along the X direction cell. and up to this is it's a constant velocity, and then it is increasing. So initial velocity is equal to the final velocity for x directions. So v naught is equal to vx, final velocity and initial velocities are same along the same direction. Why? Because there is no acceleration, there is no accelerations. Okay, because while we are writing this equation, so we know acceleration will be equal to change in velocity, correct? Change in velocity divided by time. In the x direction, ax equal to, we know x will be equal to 0 because the charge is not accelerating in the x direction. So in x direction, any changes are happening? No changes are happening, which means my v final velocity minus v initial velocity is equal to 0. That is called change in velocity. So if this is equal to 0 means I can say final velocity is equal to initial velocity, which means vx will be equal to ux. Both are same. So ux will be equal to vx and vx equal to ux, and which is equal to v naught. So we'll substitute for v naught will be here. So vx is nothing but v naught. We know the equations for v naught. V naught equal to x by t. Okay, so tan theta equal to QE divided by m into t into, for v naught we are substituting, v naught will be equal to what will come? X by t. So here x by t square. So tan theta will be equal to x by t square. From this equations and this equations, tan theta is the amount of deflection and y is the distance or the displacement traveled in the y direction. From both of this one, will come to a major conclusion is that if theta will be higher, theta is higher means what you can see. This is, suppose this is a very small theta, theta higher means higher. This value will be getting more higher and higher. So what will happen? The deflections will be more. So when the deflection is more, theta small means this much deflection, theta larger means this deflection, theta larger means this deflection. So the deflection quantity will be very high from horizontal positions to the another positions based on the value of tan theta. So whenever if you notice this equation, one important parameter is called, you can see charge by mass. This is important. Note down on your notebook. Charge by mass. Charge by mass is called specific charge. So write down a small subheading on your notebook side. Specific charge. Specific charge. Specific charge equal to charge by mass. Charge by mass is called specific charge. So whenever specific charge is higher, Q by M is higher, tan theta is higher. Correct. Q by M is higher means tan theta. Tan theta higher means more deflection. Tan theta higher means more deflection. This is the conclusions from this topic. Okay. So let's take one examples. We'll take a couple of examples and we'll see what are all the context in which these questions are coming. This is one of the questions I told you. Charge by mass is higher means more deflections will be higher. I'll tell you one example based on the concepts what we have learned now. Okay, so let's take one example and based on that we will prove, we will see how normally the questions are coming or how they are asking. I'll tell you one couple of examples. So the first example I would like to see, we'll draw the questions will be asking you like this one. We have a plates, whatever we have seen now, we have a positive plates and we have a negative plates. They will give you like a 4 set of diagrams. One is like this, one is like this, and one is like this, and one is like this. Then they will give you A, B, C, D. They will give you like this one. So easily they can create 4 options and then they can trap you, right? But we will never come to a trap. We will answer this one. Here it is saying which of this following. So here a charged particle, 4 different charged particles which are throwing into an electric field. Which of this charged particle will have the highest specific charge or highest charge by mass ratio? I told one cases to you. Highest charge by ratio, highest charge by mass ratio, which means highest specific charge. Highest specific charge means what is higher? Tan theta will be higher. So we know tan theta is proportional to charge by mass. So whenever charge by mass is higher, tan theta will be higher. When tan theta will be higher, which means deflection is higher. So now you know which one in the graph A, B, C, D out of the 4 options, which one will have the highest charge by mass. Answer is option D. This is my first examples to you. Okay, highest charge by mass ratio is available, a body which will having the highest deflections. Hope you understood the things. So based on this one, they can ask a lot of questions. So here one important point I have to say, for the whole derivations things, whatever we have seen for the y equations and whatever we have seen for the tan theta equation, all these equations we have not considering any gravity effects. So all this have done with an assumption that this is under a gravity free region. Gravity free region. Whenever a gravity will be coming to picture, the story will be getting changes. Okay, we'll see one examples in the coming area. In the coming sessions also we'll see one examples. Based on this, in the coming topic we'll see one examples based on what will happen if you are taking gravity into considerations, and without a gravity what will take into considerations. We'll do some few more examples and then we'll see. Okay, let's move to the next examples. So here we have one examples are there similar to the previous one I have done, but slightly different. Here you can see we have a positive plates, we have a negative plates for S, and we have a charged particle Q, and we are initially thrown with the velocity V0, but the condition is given in this question is at what velocity, write down, draw the diagram and write down, at what V0 the charge has to throw such that it just crosses the plate. What velocity I have to throw such that it will just crosses the plate. So the plate width is D and the plate length is L, and this is starting at a position of D by 2. So we know the fundamentals, how we know. So this is a kind of questions which will ask, but here to answer this one, if you by heart some formula, no use, nothing we cannot do, but if you know the concept, we can derive the things. Now you know, as like I told in the first topic, this is a two-dimensional motion. So we have a couple of x equations and we have a couple of y equations are there. So we will write the equations. We will write x equation and we will write y equation. So once we are writing, something will come to our mind. So we want to find out the minimum velocity or the velocity V0 such that it just crosses the plate. So we don't want to throw with a very high velocity, but a minimum certain velocities are required such that it just crosses the plate. That is the intention. So this means we need to find out the minimum value of V0, not the maximum value. Maximum value means it will shoot for a long distance. It's not required, right? We need a minimum distance. So x and y equations we will write as like what we have done previously also. What is the x equation? S is equal to ut plus half at square. So I'll write that equation first. S is equal to ut plus half at square from first year physics. Half at square. S is this distance. So this is nothing but L. L will be equal to initial velocity is V0 into what is the velocity? V0 into T, ut. Okay, ut plus half at square. Okay, so here what is the acceleration in the x direction? So it is 0. So here we know V0 will be equal to L by T. We'll keep it here. We'll go to the y section area, and y section s equal to ut plus half at square. What is the y length will be here? It is nothing but d by 2. It's given in the question. So this is the y deflection. ut, what is the velocity in the y direction? It is 0t. So plus half into ay. This is also in gravity free space. We are not considering any gravity. So QE divided by M, F by M is called accelerations. QE by M, we already discussed, right? Into T square. Okay, so we'll simplify these steps and we'll find the answer for V naught. Our aim is to find out V naught. In this V naught, if you look at, if you compare the questions with what we got, V naught is equal to L by T. L is given in the question. So answer is also in terms of what we say, the parameter which is given in the question. So L is given, so V naught equal to L by T, but T is not given. T is just our assumptions. I have taken, T is a time taken. It's not given in the question. So this T is not allowed will be here because it's my assumed parameter, not the given parameter. Answer should be always in terms of given parameters, not in assumed parameter. Assumed parameter means I assumed T. Maybe some other, my other friend is will be used with a capital T. So I cannot say like that he is correct or I am correct. I cannot say. So always answer should be with the given parameter. So here we have to find out T and we'll substitute here. This is what we are going to do will be here. This 2 is multiplying here, so 2 will get cancelled. So T will be equal to what will come? MD divided by QE into root, square root. So I am putting 1 by 2. We'll substitute here. So V0 is a minimum velocity required, L divided by T. T means MT divided by QE whole power 1 by 2. This is the answer for the question. Okay. M is called what, sir? M is called mass of the charged particle. So Q by M, we know Q by M is called a charge ratio. This we can alternatively with one more steps we can written as V0 into QE will go to numerator. So V0 will be equal to root L into root of QE divided by MD. We just rearrange it. So this is a minimum velocity in which we have to throw such that the body, the charge Q will undergo a trajectory motion and it will crosses this plate. In this case you can see I have a charge. So here electric field direction is what direction? Positive to negative electric field direction. What is the force direction? I know the force equation QE. I look Q is positive or negative. Q is positive. So Q. So what is the force direction? Force direction is also same as electric field direction. That's what this positive charged particle is going like this one. In our first derivation we have seen electrons are going like this one because my force is negative. Here force is positive. That's what it is coming down. Hope you understood. Now in this case in the last topic and this topic also I told I considered a gravity free area. I told it's a gravity. Whenever a gravity is coming to pictures, what will happen in these motions? We have written accelerate. There is no acceleration in the x direction. This is actually x direction acceleration. That's what ax will be equal to 0. We have written ax will be equal to 0 and ay will be equal to QE divided by m. What is the direction of this acceleration? Charge is a scalar quantity, mass is a scalar quantity, electric field is a vector quantity. So arrow mark, acceleration is arrow mark. So electric field direction is same as acceleration direction, which means ay direction is like this. Whenever we are considering the gravity, so this equations in gravity free space, in gravity free space there is no gravity. So whenever a gravity coming to pictures, what will happen? This ay will be getting changed. So whenever a gravity will be coming to place, so this is for a gravity free space. Whenever a gravity is coming, so ay in bracket I am writing with gravity. With the gravity means what will happen? We have a g is also the acceleration due to gravity. If two vectors are in the same directions, what will do? Will add or subtract? Will add. Many times I told, right? We will add. If two vectors are same directions, will add. So in this case, what is acceleration? QE divided by m. This is an acceleration due to electric field plus g will come. So which means if you are altering this equation with the gravity, you can say like that QE by m. It's already is called an acceleration quantity. So instead of this AE by m, you have to add what you'll do? You have to add plus g quantity. You also has to add. So plus g quantity will be coming this equation, sir. So we know this equation, sir. Here QE by M is called. So if you are doing this equation, sir, the difference is like AY will be getting changes. We'll start from here. So what you will get? D by 2 will be equal to 0. T will go half AT square. So half AT means QE by M into what will come? G into T square. 2 will get cancelled, sir. And we know T will be equal to whole D divided by QE divided by M plus G. So this is whole power root 1 by 2. So we know this equation and we'll substitute here. So V naught will be equal to L by T. So L divided by T. What is T? Already we know. D divided by QE plus M into G, and this is whole power of D divided by QE plus M whole power of 1 by 2. This is in gravity free space, but the last equation is with in gravity free space, and here it is with gravity. This is with respect to gravity. There is no difference. So this is in place of gravity and this is without gravity. Never by heart this equation at any cost, never by heart, but always understand the writing of x equation, writing of y equation, understand the concept. Rest of the things we are just playing as mathematics. Okay, so never by heart anything out of especially the right side of all this area, never by heart. This, if we have gravity will be there, we will add G into this term. This is what we have done, plus G we have added because two vectors are in the same direction. If question is specified gravity free space, or they have not mentioned anything about gravity, you are free to take G will be equal to 0 because there is no G in gravity free space area. Whenever a gravity consideration is given in the question, you have to add extra G also. It's all depends upon how you have tackling these questions. Okay, hope you understood this second example also. We're going to do the third example. Okay, so here the question is like we have a positive plates, we have a negative plates, and at what velocity u, the initial velocity u, I have to throw the charged particle is q, have to throw the charged particles q such that it will just touches the upper plate and fall down, which means the motion of the charged particle is like this. It is just touches the upper plate and it is falling down. At what velocity I have to throw such that it is touches the upper plate and fall down. Okay, the beauty of this chapter is like normally I have to say something. Normally the beauty of this chapter is like we can always connect certain chapters in physics. Always there is a connection. That's the beauty of physics. For example, now we have used equation s equal to ut plus half at square, right? While we are writing x equations, while we are writing y equations, which means that what? We are connecting electrostatics chapter with the 1D motion you have learned in your 11th standard. Similarly, we can connect this concept with a lot of other concept. For example, now here I am going to use, now we know this is like a projectile motion. Okay, hope you remember at least the diagram you have learned in 11th, projectile motion. So here I am going to connect electrostatics with projectile motion. This is one option. Another option is I can still connect this various examples of electrostatics problem with circular motion. I can connect with oscillation. So there are a lot of chances will be there. The questions are connected between the chapters. Normally if you look into the entrance examination questions, there are questions will be there specifically from each and every chapters, but always the rank deciding questions, especially in physics, are always connected with multiple chapters. This is a best example of a rank deciding examples. Okay, why I am telling like this is connections with the projectile motions. We'll see how to solve this one without wasting the time. So we'll move to here. It's a projectile motions with a velocity we are throwing with a velocity called u. What is the minimum velocity I have to throw such that it just touches the upper plate and coming down? So here we know one concept, right, which is called the maximum height. We know the concept from maximum height. What is the equation for maximum height? If you remember also, if you are not remembering also, no problem, just write it down. U square sine square theta divided by 2g. Again, two cases will be here: gravity area, gravity free space area. So depends upon the questions, we have to take the total effective value of gravity, acceleration due to gravity. U square is this velocity we have to find, and the maximum height is given as L equal to U square sine square theta, means sine square 37 divided by, if it is question is asking in a gravity free area, then no, G has to add. If question is asking with gravity, then G has to add. So I am assuming gravity free area. Okay, gravity free area, I am assuming this one. So what will come? U square has to find it out, sine square 37. Okay, we'll complete these steps itself, right? In the steps we have not written G effective. What is acceleration due to gravity? QE by m. Force divided by mass is called, F by m is called accelerations. Now we have to see sine 37. This 37 value you have to remember. Sometimes it may be given in the question, sometimes it may not be given in the questions, but whatever. So you have to remember these values. This is 3, 4, 5. I remember like this with a triangle. You can also follow the same method. This is called 37. So sine 37 if you take means opposite side by hypotenuse. Cos 37 means opposite side by adjacent side by hypotenuse. So cos 37 means 4 by 5. Sin 37 means 3 by 5. Tan 45 means tan 37 means 3 by 4. So remember this triangle. This is what I normally do. So we'll substitute will be here. L will be equal to U square into sin 37 opposite by hypotenuse 3 by 5. So 9 by 25 square on it. So 9 by 25 2 into QE divided by M. Here they are expected to calculate the value of U. So what is U square? First we'll find U square. We'll multiply this one, right? So 2 into QE divided by M. Denominator into M into L divided by 9 by 25. So we can just arrange one. 25 will go to numerator. So 50 QEL whole divided by 9 times of M. This is U. So this is U with root. Here you can simplify, but I'll keep it as like this one. So here why I have taken this just example is like to show how we can connect across the different chapters. For examples with electrostatics we have connected with the whatever we have learning for projectile motions. We will do one more example, then we'll move to the next topic. Okay. I have to show one more example or one or two examples also with the help of which is actually coming from. Just pause the video and write down the steps. Then we have to see one more example from circular motions. Okay, so let's take one example from a circular motion. Now the same story will be here, but there is a slight difference will be there. Let's see. I have an electric plate. Let marks this as example number 4. So I have an electric plate plus. I have a negative plate minus. Now if I have an charged particle Q is throwing like this one, what should be the minimum velocity V I have to give such that this will undergo a circular motion. So electric field with the circular motions. In a circular motion, I don't know whether you remember or not, the minimum velocity in which we have given, this is in first year circular motions we have learning, like 11th, but if you not remember or remember also it's fine, we can learn it now itself at least. Okay, so this is the minimum velocity in which we have to given the lower part of the motion is equal to root of 5 GR, and upper part also you can maybe remember GR. These are the common thing. So if I am giving a velocity 5 GR velocity on the bottom, then it can able to complete one full circle. So 5 GR will be here, then it can complete a full circle. It can cross upper and come back. So 5 gr is a minimum velocity. So if you know this from first year, we can just substitute. So the minimum velocity is required to complete the circular motion is root 5 gr. G is effective in gravity free area 5 into QE by m into r is this radius. This is in gravity free area. If question is asking with the gravity area, then we can say 5 into you know, right, QE by m, G effective into acceleration due to gravity into r. R is the radius of the circular motion. This is no gravity, this is without gravity. So no gravity, no, let's make some space. So no gravity, this is with gravity. So two cases we have, right? No gravity and with the gravity. This is also one example. I have connected circular motions with the electrostatics. Next, similarly we have learned some concept in oscillation also, first year oscillation also. Okay, I'm not going with an examples, but I'm telling you the concepts. I hope you remember this formula also. T is equal to 2 pi into root of L by G. L is the pendulum length. Okay, that pendulum length. So here in this case also for G, similar to what we have done, QE by M, you can substitute QE divided by M in gravity free area. With the gravity area, you can substitute QE by M plus G. This is also can ask us another type of example. So whenever G will be coming, you can substitute QE by M in short. Okay, so there are multiple ways which they will connect your first year chapters with the second year chapters. So you should be little bit thorough about or little bit remember about what you have learned it in the first year also. But else just to revise it while I am telling, because I'm not skipping that area. I'm also speaking about at least whatever you required it to hear to solve this question. So that's what I told. Always there are some rank designing questions will be there which will be connecting across the chapters, which is quite interesting and nice to do that. Okay.